on the server with my hair like that for somebody's wedding and I was asked to leave.
That's awesome.
Listen,
What a way to get out of the wedding.
We don't want you in the wedding. You can actually make like $50 doing that. You get like that.
Oh, really?
So much better. Hello and welcome to another episode of the CAD Dimensions 3D Printing Podcast. We like to get together each and every month to have a conversation around 3D printing and technology in the world today. It's our mission to help engineers everywhere have the best tools possible that empower them to impact the world, and we think doing this podcast is just one small way that we can do that. My name is Adam Fosnod. I'm a 3D printing applications engineer, and joining me today is...
Ken Postal, application engineer.
And I am Ben, and I'm the marketing guy. Oh, shoot, and video guy. Yeah.
I'm Kevin. I'm also a marketing guy. But I like talking 3D printing, so I appreciate you guys having us here.
Anytime, Kevin. I wish all of our titles would just be 3D printing guy, marketing guy,
right?
Or marketing gal. Just drop the formality. We all know what we do here, right?
To tell you the truth, I forgot what my actual title is.
Yeah?
Yeah.
I think I forgot my official title like a week after I started working here. Because the actual title I got hired for was like 3D printing solution technical specialist of hardware. It was just a mouthful, and I'm like, I'm an engineer. I do 3D printing stuff. Can we just?
It's easier to put that on a door.
Yeah, exactly. Kicking off this episode is warming up our brains with Ben. So Ben had a pretty interesting take on this for this episode.
I thought I'd change it up a little bit, and I'm going to quiz you guys. So I hope I don't embarrass you. But I have 5 different malfunctions that have to do with 3D printing. One of them's a little bit of a curveball, and I think you'll know which one that is. But I want you to tell me what you think went wrong. Like, what do you think the issue is? If it has a name, tell me the name. I don't know if they all have terms. And then tell me what you would do to fix it or prevent it from happening again. So let me just pull up my PowerPoint. I can't remember where I put it.
We're doing this live. We haven't seen any of these issues before, and I think what we should do is we should alternate who answers first, right?
Sure. Okay. Do you guys see a white screen?
Mm-hmm. Yes.
What in the world is this?
Ooh. That's a terrible looking print. Ken, you take this first one. I'll answer second.
Yeah, I see a lot of stringing and probably a bit of under extrusion. Because you can tell by the bubbles, it looks like there's bubbles in the print. That usually means that there's not enough material being printed. And then obviously the wisps everywhere is just, usually that's when when the head of the printer moves from one area to another without actually printing any material, and you get a little bit that oozes out as it's traveling and it connects, and that's how you get those wisps.
Is that the result of a head that needs to be cleaned or adjusting the flow?
Probably has to do with both temperature and what's called retraction. So when the head actually goes from one area to the other where it's not printing, most printers will pull the filament back in a little bit. And sometimes, depending on your settings, you might have to pull it in farther or turn the temperature down a little bit.
All right, I'm going to stop sharing so we can actually discuss it. But, okay, Adam, what do you think? And then how?
I agree with everything Ken said. I would also add that cooling could be a factor. And judging by the surface texture of the print and the color, I have a feeling that this might be a wood-filled PLA filament. And so those...
Did you say wood-filled?
I did. They make wood-filled PLAs, which now that you have a printer at home, you should absolutely pick some up. But it can be a little trickier to print with. It does smell like wood when you're printing with it, which is kind of cool.
That's a benefit,
it's essentially
I think.
sawdust mixed in the plastic. And so that is mostly an aesthetic thing that you might want for your prints. It can sand a little bit easier, but also the flow out of the nozzle can be a little trickier to work with, which I think could be causing the under extrusion and the stringing that Ken mentioned.
Yeah, usually you have to slow down for those specialty filaments.
Yeah.
Just because it's harder to extrude.
Apart from a more pleasant smell, is there another benefit to the wood filament?
Aesthetics. So it tends to look nice. Anytime you add like carbon fiber or glass fiber or there's even some plant fiber matte, like matte versus glossy filaments, and so those tend to disguise layer lines better than just a pure unfilled plastic.
Got it. Cool.
All right. Are you guys ready for the next one? Oh, sorry.
Sure. Oh, some of the materials, like they even have like bronze fill, which is a metal powder, and when you sand that one back, it actually has kind of a bronze metal look to it.
That's cool.
Very cool. Okay, guys. So the next one. Actually, no. Before I show you the next one, let me go back to my screen share. Can I now switch it?
That looks like it was going to be Pumbaa from The Lion King, maybe.
Okay.
Ben, did you guess what it was?
I didn't. I will.
No?
I will give credit where credit is due in the description. So does this make sense then? This is basically what you were talking about, and I think they were guessing also. I don't know if this is actually what happened, but it was their best guess. All right, you guys ready for the next one?
Ready.
All right, I need a drum roll. So I want you to look at it, and then I'm going to go back to us so we can talk about it. All right.
Oh boy.
Yeah.
All right.
Think about it for a second.
I'll answer first on this one.
Okay.
This is easy.
Okay.
This is one of those classic 3D print failures where the print itself got knocked over on the build plate. This usually happens when there's a really small surface area on your first layer, and then maybe it gets wider at the top of the print, and so there's not enough keeping it in place on the build tray. It falls over, and then the printer just keeps printing in midair, so you end up with just a big bird's nest when you come back to it in the morning. It's very frustrating.
That happened during our stress test, like 3 times before we could actually get it
Yes.
printed properly.
Right, because I screwed up the support settings, and so it fell over.
Yep.
That's it. It happens to everybody from time to time.
If it's not from falling over, it's probably from just unsticking from the bed entirely. I've had cases where the whole model will be moving along with the head because it came completely undone from the base.
How do you fix that? Or prevent it?
Better
It
design?
depends on the printer and your build surface. So, not with printers that we sell, but with at-home printers and cheaper models. There's a big variety of what build plate you're actually printing on and what that surface is. So some of the most popular are build tack surface, which is just a textured plastic that the filament sticks to really nicely. Some people prefer just printing on glass. Some people prefer doing glass plus glue stick or glass plus hairspray.
I was going to say PAM, maybe like non-stick cooking spray.
Yeah, that's the opposite of what we want, actually.
That would
But
guarantee
it'll come
a
off
failure.
easy.
Right, but it'll also never stick to the actual surface. It really there's a lot of variety there. So apart from just looking at the print surface as a whole, what I'd call the Z offset, right? So every printer will have a Z end stop that it'll touch off, and then it uses that location to determine how close or far away from the build plate it should be. And you can adjust that end stop. Some of them it's a physical adjustment, some of them it's adjusted in software, but sometimes you need your nozzle closer or further away to the actual build plate.
Yeah, and with our machines, typically one of 2 things you can do. One be to just recalibrate the layer height. That's usually the easy one. And number 2 is if you have really tall, thin models, you may actually need support to hold that tower up while it's printing.
So you would use surround support instead of most of the default support settings for Stratasys printers.
Not accounting for an overhang or an odd geometry, but just to give it stability.
Yeah.
Breakaways, right? Would they most likely be a breakaway support?
One of the kind of funny challenges with really high-end printers is they go so fast that they can actually knock over small components. So sometimes, like either the surround support or even using just a dedicated wall, like I know they have wall supports you can use too, they'll hold the model in place while it's printing.
That is good to know. All right, guys. Are you ready for the next one?
Let's go.
I'm anxious for the next one.
Is there an
pretty
answer
fun.
for that one?
Yep, I'll go to that.
The last one looked like it could have been an art installation also.
I think it looks nice in a really weird way.
Yeah.
Yep. And you hit the nail on the head
Probably your
with
bad.
not sticking.
Told you, classic spaghetti print. Bird's nest.
So, okay, I was going to say spaghetti because it's sticking to the sauce, and that's where I went to. Spaghetti
All right,
because
you-
it looks like spaghetti.
All right, here's the next one. This is a little harder.
Ew.
Ooh.
Give you a few seconds, and then I'll show our screen again. All right. What do you think?
I think Kevin's up, right?
Oh, I don't know. So why don't you, one of you guys answer?
Ken, this is one that you got to answer first. What do you think? It's okay to be wrong. It's only recorded and distributed across the world.
On the internet, yep.
It's just your reputation.
It looked a little bit at the top like you might have had some layer shifting. It's probably not the worst thing, but
What's layer shifting for those who don't know?
it's kind of hard to describe. But basically, you print a layer, and then typically with printers that use belt systems, what they might do is when they move real quickly, they may skip a tooth on the gear, and so the head won't actually be where it thinks it is, and it'll actually start printing the exact same pattern, just slightly off center. And that's how you end up with parts that look like the layers are perfect, but they're all like shifted like a Jenga set almost. Also on that one, probably again, some extrusion problems because you've got really weird, inconsistent layer lines.
Do you guys have like a triage process for when you see problem prints like that? Like is temperature the first thing you look at, and then the design, and then, you know, some of these other environmental factors?
I don't personally have like a step-by-step process. I just have a lot of experience troubleshooting things where I can look at it and get a pretty good idea.
I'm sure
about you,
you
Ken?
don't see a lot of that, like something that bad with our printers, though.
No, but at home I see it all the time.
Oh, really?
Yeah, all the time. I've been fighting with my one printer. You can sort of see it right there. I've been fighting with that one for the last 4 days, right? I had a nozzle jam. I tried everything in the book, cleaning filament, cold pulls, hypodermic needle, up the nozzle. Finally just had to bite the bullet and replace the nozzle, and then the thermistor kept popping out, and it...
Thermistor?
Thermistor, yeah, it's
That's
the
a
temperature
fabulous word.
sensor in the hot end.
That's
It's
terrific.
a thermal resistor, so it changes in resistance. This isn't what we normally talk about on the podcast.
The word thermistor just got me. I was like, what the hell is that?
I gotcha. Anyway,
But you've
about
seen
that
a lot.
picture of the failed print. I've seen a lot of stuff, Kevin.
Yeah.
I've seen a lot of stuff. I think this print largely boils down to a cooling issue. I'm not 100% committed to that answer, but that's my best guess. I think it could be one of two things. I think the most likely thing is that this person is trying to print ABS material in a non-enclosed printer. And ABS likes to take its time to cool, and when it doesn't have enough time to cool down and settle into its shape, it likes to warp up. And so I think that's what we're seeing on those overhangs of the print, is it's warping up, and then and then the nozzle is kind of dragging along there, and so that's why the print looks a little bit melted. The other possibility is that they're doing PLA or PETG, and they don't have their cooling settings dialed in right. They need more cooling.
You're pretty good at this.
Yeah.
Okay.
Thank you. I hope I'm right.
Are you ready to see the answer? Oh, wait, and Ken, what did you say it was? What was...
I thought it may be a little bit of layer shifting and then
Okay.
probably some like under extrusion again. Not bad, but definitely there.
Okay. Drum roll.
Am I the only one drum rolling? Is that what's
I hear
happening?
Yes. Yeah. It is audible, yeah.
Layer cooling.
Look at that.
Overheating, and it didn't tell me what the type of material was. Okay. Does that make sense to you? That's basically what you said.
Yeah.
Yeah.
It could have been layer shifting. It could have been a loose belt.
Could it be both?
It could be both.
In theory?
I need
Okay.
more pictures. I need more pictures to determine which one it is.
One thing to keep in mind when you're talking about like examining prints or failed prints, if you're the one that set it up, usually you know what settings were used, and that's a dead giveaway right there. When you walk up and something's wrong, if you know how it was supposed to be in the first place.
Mm-hmm. All right. I'm going to go to the next one now.
Ben, this is fun. I like this game.
I was going to say we should start.
I do too.
We should get people to send us their failed prints and see if we can diagnose it for them.
Yeah, that'd be awesome.
That'd be fun. Ooh.
So just take this in for a minute, and then I'll gather your thoughts, and then tell me about it. You ready?
Ready?
Okay. What was that?
That was a printer that caught fire. So, in
I
case you
think
couldn't tell.
that's pretty. That's low hanging fruit.
Yeah, Ken, you're getting all the hard ones.
By the way,
So
that was
why-
from an
Adam,
article. That was from
Why
an
did it
article.
catch fire?
Yeah. Why would it? What would make a printer catch fire?
That news article, by the way, was: Is your 3D printer trying to kill you?
That is a clickbaity title.
Yeah. Right.
was.
So, on all 3D printers, especially common hobby 3D printers, this is really important. It has a setting in the firmware on the machine called thermal runaway. And what that does is if anything happens to the wiring on the printer, it'll shut itself off completely. That way it doesn't accidentally keep heating and overheating. I just talked 2 minutes ago about the thermistor on my printer having issues, and it kept coming out. If thermal runaway was disabled on my printer, the printer would just keep heating. It wouldn't know how hot it was, and eventually it would catch on fire or it would short out and break the wires, which can be very bad. This has been a controversial issue. You heard in the 3D printing community for quite a while, because most printers at the hobby level and even somewhat at the prosumer semi-professional level pretty much all run the same firmware. It's called Marlin, and by default in the configuration, thermal runaway is turned on. But for a long time with the really cheap printers, they didn't have very high quality components that could heat up quickly. And so what the manufacturers did was they actually turned off this setting to help the printers heat up more quickly. And then if the thermistor failed or it came out of the hot end for any reason, the printer catches on fire.
That sounds like a safety
Basically,
answer.
the biggest issue with that was you didn't know. Unless you went into your printer's firmware, you would never know if it was turned on. So it became a thing for a while that if you bought a super cheap 3D printer, or even to those lower level prosumers, really push people to go and look at the firmware to make sure that's active. It seems like now most of the major manufacturers have figured it out. I would still check, but the people at least in this picture you showed, that company I know has switched to permanently putting it on.
Now, why does turning it on slow down the heat up time?
It shouldn't. It's really just a testament to how cheap the components were.
Yeah,
Where?
I thought also part of the issue was like the sensor couldn't accurately read the temperature. So, like if let's say we're trying to get to 200 Celsius, the thermistor may spike and accidentally read 240, which is way out of the range, and it would immediately kill the printer.
Right.
Like just turn everything off.
Yeah.
So it wasn't it was doing what it was intended to do, but because the thermistor was so low quality, every time you would try and turn on your printer, it would just say, "Oh, it failed. It overheated."
I see how that could get annoying.
Yeah.
I also see how your
I'm-
house being burned down would be annoying too, though.
That'd be worse. Yeah.
Yeah.
I'm guilty of with my first printer. I always had it turned off. Just wasn't worth it
Yeah.
because of the temperature reading fluctuations. What it does is you can go in the firmware and set it like every 3 seconds, check the temperature, and you can change that number. If it's plus or minus 5 degrees, then you're fine. And again, you can change that degree tolerance. Sometimes it's easier just to turn it off.
Makes sense.
All right, so you totally got that one right. Let me go back to the slideshow. So you got that right. Yep. By the way, I had to choose between either this one or I found a bunch of 3D printers that would like throw themselves off of the table. And
What?
Off the
I thought
table.
that was I thought that was pretty funny. There were like two issues for it. It's like you didn't secure your printer down, and like when it moved, it would like slowly creep over to the side of the table until it would eventually kill itself. Or like the filament was attached over here and it wasn't releasing fast enough. And so if your filament was away from the table, it would just pull itself and
spooling
then kill
off
itself.
and just pulling it with it.
So my first printer, I walked in one time because the filament was bolted to the wall. There was a spool on the wall, and it got basically coiled on itself, so it wouldn't spin anymore. So the printer actually raised itself up. The gears were strong enough to raise the entire printer up to the top of the filament before it stopped. It got jammed.
It tried to hang itself.
It was a really light, little, tiny printer, but I just walked in and I was like, okay, this isn't right. Why is it floating?
Yeah, your printer should never be like swinging around, right? Especially during a print.
Not ideally.
Oh boy. All right, on to
You
the
want a
next
stable
one.
surface. Ooh.
The curveball.
It looks like it's growing something.
Yeah, I believe this is the same print, and then they painted the bottom.
Okay.
Yeah, because you can kind of see the yellow going through the green. I think. So my two questions for you. Why are the two prints different colors? Do you think they tried to paint it, or is that on purpose? And also, how the heck did they get it to go that far in one direction with no support material and then straight up? The curveball.
This,
How do you
this
know?
is definitely a curveball.
How do you know
What do
they
you
didn't
think?
use support material?
Oh,
Could have just broken it away afterwards.
Well, according to this article or list, I forgot where I found this one, there was no support material, apparently. So just going off of that, just whether or not it's true, if there was no support material used, how was it done? Or is it just
I
not
think this
possible?
is a. Sorry, who's talking?
The delay,
I
man.
think this is a layer shift. I do. I think
That bad?
a couple key factors here. It's all in one direction, which indicates that one of the motors probably failed or overheated and stalled. That's a common reason why a layer shift might happen. It was able to print in midair like that because it looks like it did a circle and then went up to the next layer and did a circle. And so you essentially got kind of like a stair-stepping technique followed by a ton of cooling because it looks like it was supposed to be like a thin cylinder that came out of that part. And so the cooling would have been turned up quite a bit on that fin feature. And so you were able to just kind of keep stair-stepping even though the motor failed. And then either the motor cooled down enough to recover so that it could keep printing up in kind of a cylinder shape like it was supposed to. It's probably my best guess.
Very
Could you
believable.
go back to the picture real quick?
Yeah, sure. Nothing's fast.
You
It
sold
could
me on
also-
that explanation, Adam, because it looked like it was growing something to me.
It could also be different colors because this could be thermochromic filament that changes color dependent on temperature. And so at elevated temperatures it would be yellow, and at lower temperatures it would be green. So I think in the picture on the desk it had freshly come off the build tray and the yellow part is still a little bit warm. Versus in the picture on the right, the whole thing's warm because it has a heated bed.
I can't remember the name. When I was applying to colleges, I think it's the New York School of Arts or Fine Arts, whatever it was, and they sent me their packet, and it had that material on the top of their packet. And when you put your hand on it, then a map of New York City showed behind it, and then there was like a piece of artwork in front of it.
That's
it was so
cool.
I kept
That's
it for so
awesome.
long. I had no intention of even going there, and I'd be like, "Oh, look, it's my face in New York City."
It's like a mood ring, you know?
yeah.
That's cool.
Okay, Ken.
Yeah, I don't know. I don't know if it was layer shifting because like the distance it went was so long and such a short height. That's why I'm a little confused because
Wind.
if it did layer shift, it would like incrementally move up. And because that cylinder was so tiny, I'd be amazed that it went that far in that short amount of distance. I don't know. The color changing makes sense, like the different temperature to get different color.
What was that called? Thermochromic?
Yep.
Yeah, I don't know about the tab. Yeah.
What's
I would love to
what's
see
the
the
answer
file.
here, Ben?
All right, let me pull it back up.
Inquiring minds need to know.
Oh, come on.
Wait a minute.
The only guess that this article had was basically word for word what Adam said. And I was very impressed. I almost thought you wrote the article. So it talked about it had to have been a really cold room, and the glass would have helped, so it would have been able to cool fast enough for it to not need supports. And it really talked about temperature a lot, and then they said after that, I just want to see the file. I have no idea. So I think Adam has the best guess because he guessed exactly what they said and then some. Made sense to me.
Did it not look like an injection mold, though? Like a housing for an injection mold? Why would you want, like, what would you be making that you would want that thermo reaction?
I think mostly...
Thermochromic, right? Did I get it right?
Yeah.
Okay.
Look at us, dropping all sorts
That's my SAT word for the week right there. That's a good one.
I think it's mostly like a gimmick. I don't know of any like practical industrial applications using thermochromic materials, but that's just
I was just
me.
curious. Yeah, I didn't know if maybe, tracking if it was, warm in the room and you'd look to see what color it is. I don't know.
I think it's mostly like a...
Your coffee cups have it, like different things. It's mostly a gag gift. Or to try to get kids to apply to their school, I guess.
Yeah, I've seen...
My kids have it on a pencil.
Yep.
I've seen filaments that like change color when they're heated differently. So like if you put it in the fridge or if you just hold it in your hand for a while, it'll change color. But I've yet to come across anyone that needs the filament on its own to change colors midway through the print instead of just stopping and changing the color of the filament.
And you wouldn't use like fill material, like you wouldn't waste that on the inside where it's not going to get exposed. So I don't know, odd application. Maybe.
I also have seen UV reactive filaments where, like, if you have it inside, it's white, and if you take it outside, it turns pink. Like, it's neat, but I don't know of anyone using it for practical things.
Yeah. Well, there's got to be a use case somewhere, I'm sure.
Yeah, you see that in glasses where basically they're never fully dark outside and they're never fully opaque inside. And so you just have people with bad eyesight that are having a really hard time wherever they are.
What?
That's not the point of glasses.
Yeah, you know the lenses that react to light? Yeah.
Transition ones.
Transition, yep. Maybe that's different. But anyway, that's all I had for you. One curveball. I had a lot of fun finding those images too.
That was fun. I think next time we need to keep it to like 3 pictures though, because that segment took up way too much of our podcast. But it was fun.
I was gonna do 10, and I thought, maybe 5 is all we need. That'll be pretty quick. Apparently not.
Now we know. Knowing's half the battle.
Yeah.
We move on to our next segment now. Kevin, you have an awesome story to share with us.
Yeah, so, everything in the news cycle seems to be related to a lot of very specific things, and 3D printing hasn't had an enormous amount of, we like to bring articles and topics that are new or somebody's, pushing the boundaries in some way, and we have something that relates back to real-world practicality. And we found an article about GM using 3D printing to power their medical manufacturing. And we wanted to talk about it because it was a really, really good use case for like the best possible way you could use 3D printing, which was when, GM at the start of, I believe it was Q2, was asked by the federal government to produce ventilators in response to the COVID outbreak. They, along with a lot of other companies, turned to 3D printing to make the bridge from, what they had with their partner from Ventec Life Systems to get to a place where they could mass produce the 30,000 ventilators that were on order for the end of August. And so we wanted to talk about it just because we think that that's a really incredibly good use case for the way that 3D printing can help take that bridge from I'm going to ramp up production. I'm going to get to the place where I've got my, my molds where I'm stamping out, thousands and thousands. But until I get there, I've got to have something to get the ball rolling. And big companies, small companies could use 3D printing to make that transition. So it was kind of neat. And we tried not to, dwell on things COVID related, but we thought that was at least a bright spot and something to talk about. So what do you guys think? What are there any other use cases where you could think outside of the ventilator example that GE has? Obviously, they were looking at a whole change in processes from automotive manufacturing to something completely different. So they were going from square one for a lot of things. But are there other examples maybe that you guys can think of where there's other great use cases for 3D printing to do that?
I think this scenario highlights for me is the flexibility of 3D printing, right? Companies with 3D printers, GM, or otherwise.
GE probably has them too, but this article is about GM. So.
You're right. Come up with more creative company names. Anyway, it's flexible, right? Or one day you can be making prototype parts and fixtures for your assembly line, and then something like COVID happens and you can immediately switch and start making parts for ventilators. And not only 3D printers, but also the rest of your manufacturing resources, your CNC machines, your mills, your lathes, really just digital manufacturing tools that can be flexible and make multiple things, I think is the big highlight here. I think we'll reach a point where manufacturing stops relying on hard jigs, fixtures, tools, and molds to make things.
Mm-hmm. To be able to
also,
go ahead, Ken.
Go ahead.
No, it's not.
Yeah, and what they kind of highlighted in the article was GM already had all this equipment. They had already invested in it for their own internal purposes, and they highlighted that because they were able to switch so quickly is how they were able to meet that August deadline.
Right.
If they didn't have that capability, you got to go and cut all the fixturings on CNC. You got to cut your components. It's just going to take longer.
Yeah. So the article talks about how they started rapid prototyping back in the late '80s, but they opened up a specific innovation center in Michigan where they produced the first Miniature Corvette. It says was initially 75% of the parts were 3D printed. So this isn't technology that's new, and I'm sure that they've been obviously incorporating this in their processes for a long way. But yeah, to be able to say, this isn't the machine that we use to make catalytic converters, we can take this and we can say, all right, you're not making catalytic converters today. Now you're making something completely different that could go into a person's body or run a machine that is going to be a pump on your lungs. It's an entirely different application. And I think flexibility is the key word, hits it on the head.
Ken, what industries do you think would be most what's the word I'm looking for? Disrupted by the growth we're seeing in 3D printing to be able to make different components without tooling?
Sure. So when you look at it from the idea of like fixturing, I think it's been pretty obvious that aerospace, automotive have been the biggest winners for two reasons. One, because they need so many, and number two, it's so big. So when you think of some of the tools that they need, if you think of like something the size of a bumper, that's extremely expensive to go and get a metal block that big and then cut it down to the shape you need. Whereas a plastic part can be a couple $100,000, significantly cheaper. The prototyping realm has really been everybody. I mean, I can't think of anyone specifically that just stands out that much.
You could think of any company that would look to centralize things. So if you have multiple manufacturing sites in different places, now you don't need to have this GM facility in Youngstown. Sorry, not to talk about a sore subject, but this GM facility is only producing these 4 cars because we have the equipment here to only produce these 4 cars. No, we could produce everything out of every facility because they're all equipped to be as nimble. But that could apply to any multinational corporation conglomerates. I mean, you think about the DuPonts and the Raytheon manufacturers of the world that are doing these large-scale things. If you have that flexibility in all of your sites, it opens up a lot of options.
It is important to note that when you look at companies like auto manufacturing, they still very quickly hit a point where their scale requires traditional tooling. Mm-hmm. Maybe not tooling as much as just traditional methods. So if you're going to use a fixture for, I don't know, couple thousand parts, or you can get away with a couple plastic fixtures to get you through your ventilator run, that's great. But if you're going to be doing millions and millions of uses of this fixture, then it's probably worthwhile to actually cut it out of metal. And that's what you're going to see in some cases with automotive assembly, where you're making a car every few seconds. They might have the quantities where plastic can't hold up on the long term. The short term, so they can start production, yeah, that makes sense.
I'd agree with you, Ken, but I'd also challenge you that won't last forever. Looking at the car bumper example, right? That injection mold or that roto mold is insanely expensive because of how big it is. I imagine that as the 3D printing machine cost starts to come down and down and down, we'll reach a point where it makes a lot more sense to buy 2 large format 3D printers than it does to buy that injection mold. And then you just print the bumpers for any car that you need to manufacture compared to being locked into one design.
When you think about how specialized some of this equipment can be, I've been to the Budweiser factory in St. Louis, and a lot of the custom equipment is made specifically for them, and it's just there to serve that one function. You want to buy another one, it's coming with a really, really, really big price tag. And yeah, I think that it's a matter of time.
Yeah, injection molding is one that really stands out in my mind. I think the other one is casting. Sand casting, investment casting. Those tools they're so expensive, which is what urges everyone to go overseas to have them made, especially for large components, right? If you just need a small injection mold for a component the size of your fist, that's probably only $5 to $10 grand. But if you need something the size of a microwave, all of a sudden that jumps to like 80.
Right.
Whereas if you just had a few large format printers, you could probably get up and running with all the components that you need.
What tools are you talking about with investment casting?
So investment casting, typically you would start by making a metal injection mold, and then you would just inject wax into it, and then you would get the wax negatives, and then you combine those in an investment tree, if you will. So you take big chunks of wax and melt all the negatives together, and then you put those in ceramic, and then you dry the ceramic and melt out the wax, and then you melt the metal, and then you pour it into the cavities, then you break away all the ceramic, and then you cut away the tree, and then you bend the parts back into shape because of the thermal distortion.
So investment means you're spending a crap ton of money to do that.
By the way, if you want to see a really good video on investment casting, Alex Steele, he's a blacksmith. He's in the UK and he moved to Montana, I think. Anyway, he made a saber. And the guard for the saber, he decided to do it from investment casting and do it the slow way. It took, I think, like 7 20 or 30-minute episodes for him to finally figure out how to get one good handguard down. But definitely worth watching. Maybe like the first one and the last one. And if you have a lot of time, watch all of them.
Yeah, get the fast track to the good results. Compare that to metal 3D printing, right? You binder jet as many different parts as you want without making any tooling. You sinter them. Maybe you do some post machining. Yeah, it seems so much better.
Mm-hmm.
Oh yeah.
And you're not locked into one design.
Yeah, the only thing holding us back a little bit on the printing side, at least when I think back to like when I was working in aerospace investment casting, is the internal geometry accuracy. So like you said, we can cast something and then finish machine the outside to any level of precision. It really just comes down to the really high-end aerospace, the internal components, that it really just comes down to the quality of the printer. So I don't think right now we're there for some of the parts. For a lot of the parts, yeah, we're there.
But
Yeah,
these are sea changes. These take 10, 15 years for those things to catch on. And I just think that examples like GE, companies that have GM, you got me doing it. Companies that have the money to spend and these investments and push this envelope and find these use cases. That time to disrupt the market is going to be shorter and shorter.
Agreed. It'll only, like I said, I think it'll only make more and more sense down the line as machine costs comes down over time and starts spending $100,000 on an injection mold just seems silly.
So there's the news, guys. I'll be at the anchor desk all week.
I wasn't quite sure where we would go with that conversation, but I think it's a good discussion.
Yeah.
I think it ties really well into Ken's next segment of the 3D printing application of the month.
Sure. So, yeah, kind of going off Kevin's article there, I was going to talk about a little bit about production parts, so 3D printed parts that you actually use as a final product or a part of a final product. And one of the things we talked about in the GM article, the first piece of it is what's called bridge to production. Now, we talked a little bit about bridge to production in terms of tooling, but also bridge to production in terms of components. So, like I brought up where, let's say, just really hypothetical, the car industry or aerospace, let's do aerospace. Let's say you're making a lot of one type of plane. It may be more efficient to start printing all the air ducting and then switch to injection molding later on, depending on the quantities you need. But in order to hit your early deadlines, it makes more sense to print parts, even if you need a lot of them, and start shipping immediately. The second part of it is low volume production. I think this is the one that everyone knows about in terms of production 3D printed parts. This really specializes for small order, highly customized, and quick turnaround. Those are kind of the three big wins for additive in general. So if you only need a dozen of a part, or if you're only making 5 of a very specialized component, you had mentioned the I think you said like DuPont with the custom equipment. All of that stuff is one-off. There's no one's got those parts in inventory anywhere. So those are good cases where I can print specialized part holdings or fixtures or end-of-arm tools. And then finally, the last of the 3 pieces is end-of-life production. This is probably what you've thought about with like old cars, old planes, anything that no one's producing anymore. So this kind of gets into the reverse engineering industry a little bit, but instead of keeping warehouses and warehouses and warehouses of every part from every car and plane ever made, we just have a printer. We keep all of the digital designs for those parts, and when someone needs a specific component, we go and print that exact part. And that is intended to be used as a fully functional part. So really that cuts down on both physical storage space and obviously mass overhead of inventory.
So like if I had a 1997 Tacoma and I needed you to print a gasket, those are old, those aren't really being made anymore. That would just be something I'd call you up and you'd print one for me?
So yeah, in theory, like you said that was Toyota, right? Let's say Toyota had a manufacturing space. Instead of storing every year, every style of that, they would print basically the near net shaped casting and then just finish machine that one individual component to exactly what you need.
See, I went to like somebody who's restoring like a 1970s MG and they can't find, a cam header or whatever. I don't know car stuff. That might not even be a thing, but stuff like that. But so are there companies that serve that purpose, or is it up to the OEM at that point to have a plan in place to address that end of life usage? Or if you're a consumer who's bought something like that and you're just SOL, or are there third party resources to do stuff like that?
I think we've been contacted a lot about making old car parts, both for like even engine components, which I usually shy away from, at least from what I can do. But a lot of aesthetic parts that you just can't buy anymore, those are stuff we do quite frequently. I don't think you necessarily have to go to the OEM. I think that's the way it is right now, just because the OEMs, like I said, they don't want to hold on to warehouses of all this stuff forever. It's definitely been more of like a hobbyist type thing, collector, I guess. But if the OEMs could theoretically keep every single part ever made within a click of a button, I'm sure they would.
There's money to be made there in the children's toy business. I don't know where it is, but having kids, they break everything all the time. And like that's been the best use case that we've had at home for we should buy a 3D printer, is because when the stuff breaks that my kid bought, or that we got for my kid that I can't find another one of, I need to replace just this little widget. So I think that makes a lot of sense on a bigger scale.
The kids' toys isn't an area that I thought of, Kevin, but that's a really good point.
I mean, not
for,
Legos, because they're
home usage.
indestructible, but the perfect example, Ken, we never actually closed the loop on it, but my kid bashed his baseball tee and cracked the little plastic sleeve that goes around it. I got to either go back to Target and buy another $60 tee, or I could just print an 8-cent plastic ring that goes around it and problem fixed. Or electrical tape and hope he doesn't do it again.
Yeah, the only tricky part with, like, even the example you said, when the part you have has been smashed into pieces, it can be a little hard to redesign.
Harder to, recreate that, especially when it was threaded on the inside. No, I understand.
Yeah, I think this is an application that goes overlooked a lot, or a lot of people look at it who don't understand it, right? I think a lot of people look at, oh, I want a 3D print for production. That means I'm going to use a 3D printer, but I'm going to get the exact same mechanical properties, surface finish, and accuracy off of a traditional process, and I want it to cost the same. And that's just not the case. I think it just comes from a lack of understanding of the technology and really what it's capable of. But in the two specific scenarios that you mentioned, Ken, I really like the legacy parts production aspect of it, because that's something that I can point to. I know Whirlpool does it today, and I know BMW in Europe does it today with big, large-scale metal printers that then they post-machine. So it is being done by the OEMs as like a level of service to their longtime customers, of like they're still going to keep supporting
and that might
older
be
equipment.
That kind of stuff might be available for higher end brands now, BMW, if Chris Craft or whatever, like high end boats or whatever it might be. I don't think they make Chris Craft anymore, but the high end stuff will come down eventually too, and that will be more available for companies like Toyota when that's on a different scale and it's more affordable, and those things all change in kind.
Yeah, I would expect that for sure.
I can guarantee that those big brands, even if they're not the luxury brands, are already investigating a lot of this. I mean, I read an article yesterday about Stanley, Black & Decker, that's been investing heavily in everything from printing to automation, factory automation. So all the brands, the bigger brands, are in some way investigating how they can reduce costs this way.
And I believe Black & Decker is moving its manufacturing back to the United States, by the way. I think that just happened. Maybe
I read a headline that said something like that, but I don't remember the company.
I think it was Black & Decker. I think.
Yeah, but the way they got to do that is they got to find a way to make it cost effective here. And one of the ways we can get there is through these kind of additive methods.
You know what I would have loved to have seen? Craftsman. I know that was a brand that was bought by Lowe's, but for the longest time, and my father-in-law has everything Craftsman because it was really, really quality. It had a lifetime warranty. I could see a company, I mean, they don't really offer lifetime warranties much these days, but if you had a company that has something like that, you've got to keep a certain amount of this stuff on hand, right? I mean, you're kind of bound by that.
Lifetime warranty is great until the company goes up, and then,
right.
Yeah, your warranty's not very good.
Speaking of Craftsman and lifetime warranties, you know who else has a lifetime warranty on all their non-electric tools?
Harbor Freight.
Harbor Freight.
Really?
And yes.
Unaware
and
of that.
Someone who is very cheap, I appreciate
there's
low quality and lifetime warranty.
Yeah, I did not know that there's a lifetime warranty on non-electric tools.
Husky has one. If you go to, like, I think that's in Lowe's. There's a lot of places that have a lot higher quality.
Milwaukee does, right? They have
Milwaukee. A lot of places, a lot of tool companies that are obviously not electric and power tools, but more than just Harbor Freight.
So the housing for your impact driver, that cracks and it's cutting your hand. All right, I don't want to go buy another one. I'm going to spend $300 on a new impact driver. All right, no, hey, Cobalt, I just need the housing for the one side of this. Snap it on there.
Yeah, they do that. If you get your limited warranty, they'll do that for you.
Yeah.
Like the amount of power tools that people have, you can't just replace your DeWalt if it explodes on you.
How many other brands can we fit in this segment?
Yeah. Well,
you mentioned a lot of brands for not being sponsored.
I know, right?
That just happened. My brother-in-law, he dropped his DeWalt drill. I think it was his impact driver, and it actually it exploded in two directions. It was on its last leg of life. So that was fresh in my mind. But no, they do repair stuff.
Yeah.
It's basically the same price as buying a new one, but hey, they'll do it for you.
You know, if I was going to 3D print and place a housing, there's one thing that I would encourage everyone to do, and that is not to thread the bolts directly into the 3D printed part. Seamless transition to our 3D printing tip of the month.
Well
that
done.
I
That was
think,
butter smooth.
which is why I had to call it out, right? And ruin it. People should be using threaded inserts on their 3D printed parts. I'm gonna take a stance here. In my hobby life, I rarely go through the actual work to put them into the parts, but when you do, it is such much more of a reliable connection, right? So you have a hole that a bolt needs to go into in your 3D printed part, and usually I'm lazy and I will just put the screw up there and grab a drill and
Wrench it in.
push the threads into the plastic, right? But if I was gonna do it properly, I'll go ahead and share my screen while I was gonna try. I think I need your permission, Ben.
I am the Zoom king. All right, let me see how to do this.
If I was not being lazy, I would buy very affordable, we're talking like pennies,
All right,
heat
try it.
set inserts. All right.
And you can get those at hardware stores.
Hardware stores are a little difficult, but they're really just little pieces of brass. You can get them on Amazon. You can get them on eBay. They have knurling on the outside, which helps them grip into the plastic, and then they're threaded on the inside. If you are an industrial company, chances are I would bet that you have an account with Grainger or McMaster-Carr. You can find any threaded insert imaginable. These are commonly used in injection molded parts when threads are needed instead of just tapping the plastic, because the metal inserts, they have a higher hardness, and so you'll have more reliable thread pattern and hold when you're attaching two different parts together. I started making kind of like a custom example model, and I didn't get it done in time for this podcast, but I will finish that up. And what I did was I 3D printed on our J750. Ooh, I have it here with me. I 3D printed this motor, right? So this is
Very cool.
a replica of a very common small stepper motor that would be used for hobbies, and it has through holes here. And so you would put a screw through that hole and you would screw it into the threaded insert. So I drew a motor mount and printed it on the 120 yesterday, and I just need to heat up and set the inserts. You can just do it with a soldering iron. You just kind of put the insert over the hole and then put the soldering iron on it. The brass will heat up and then it'll kind of melt and sink into the plastic.
So is that like one solid just plunge and walk away, like don't fiddle with it and try to mess with it? Is it, what if the diameter of the soldering iron is smaller than what your hole is?
I've never had that problem.
Okay.
You really
Maybe it
you
happens
only
less.
Need, you only need it to touch the fitting itself, the insert, because the metal will heat up, and that's what
Okay.
lets it go through.
That's why I use brass.
Hey, do you want to share your screen again, or stop sharing?
Yeah, I can do that. The inserts are most commonly brass. I don't really know why. I think it's just because they've been used in injection molding for so long. But they do conduct heat pretty well.
Yeah.
You can get them in other materials, but brass is cheap. It's fairly hard. It conducts heat fairly well, so it's a good choice for this application.
Hey, Ken, what materials or what ways should you not do a heat insert? Do you have any
Don't use a
insight?
blowtorch. That
Don't
didn't
use-
work to heat your metal part. No, and then
That
also
failed miserably.
yeah. One other thing to keep in mind is the size of the hole you're actually putting the part in does matter. So you want it to be a little tiny bit smaller than the actual insert, but not a lot. If it's too big, then obviously you'll have nothing to grip. But if it's too small, what we did and what happened to us was we tried to set it, and we were trying to move so much plastic that we actually pushed it down, and we were getting caught on that plastic, and we couldn't actually go any farther because instead of trying to go through a hole, we were eventually trying to go through solid plastic.
And for the record,
I
the
was-
blowtorch was not Ken's idea. He's like, hey, do you have a soldering, is it kit,
Soldering iron?
gun, iron? I don't know. Obviously I don't, because I don't even know what you call it. I think I even said soldering, because I read it phonetically. But I was like, but I do have a blowtorch, if you want to try that. So we did. Didn't work
recommend.
whatsoever, but it was fun to try.
Any excuse to use a blowtorch is a fun one.
Yeah, I love being paid to light things on fire, kind of.
Wow, what a great job you have, Ben. But I would echo that tip on the hole diameter, Ken, because I definitely screwed that up with this model when I tried it earlier, and it was a little difficult to push the insert even though it was heated. And then what happened was, because I didn't make the hole wide enough, the plastic, as it melted, kind of welled back up into the threaded section and completely clogged it. So I think I can save it, but yeah. Make sure the hole's the correct diameter. Actually measure it with calipers when you're modeling it, and then make it that diameter instead of being me and just guessing what the right diameter would be. I'll save yourself some time.
Is there a formula for it?
Really just measure the outer diameter of the threaded insert, and then you can make it slightly smaller than that. And 0.2 millimeters is going to be plenty, because then it'll have material to grip into without getting in your way.
Cool.
It's part art and part science. So if you haven't tried it yet, try it on your 3D prints. It's a good idea. And I think that wraps up the episode. Right, everybody? To the audience, thank you so much for watching, if you stuck through it to this point. If you have pictures of failed prints that you want us to look at in a future episode, feel free to send those to us. You can send them to Ben directly in an envelope. Send them to his house. We'll put up the address somewhere here. Where should they send those? Should they just tag us on Twitter or something?
Make a comment.
You can add us on Twitter too, though.
Okay.
Yeah.
Can you put pictures in YouTube comments?
I don't know. No,
I feel so old asking that question.
No, you'll get flagged as spam.
I don't think you can.
Yeah, no,
Okay.
really, just any of our social media. We have Instagram.
You know what? Marketing at caddimensions.com.
Cool.
That works too.
Only
Twitter.
old people email, man.
Twitter, or if you're old school, marketing at caddimensions.com. They
We're
will
up-
take all of your photos.
We're also on
MySpace.
Instagram. You can slide into those DMs. You can send it on Facebook. You can LinkedIn.
MySpace.
MySpace.
Yes.
Friendster.
Yep.
IRC.
Reddit. We don't have a subreddit. That's ridiculous.
No, we don't have a subreddit.
Anyway,
Cool.
thank you for watching.
There is
Send
a
us
subreddit,
pictures.
though.
There is a 3D printing subreddit.
No. There is a catastrophic 3D printer subreddit.
Oh,
Yeah,
I have not been
of like
there.
bad prints. Yeah.
We should explore that in a future episode.
Yes, we
We
should.
should.
It's pretty entertaining, actually. I did that for a little bit yesterday.
If we don't get enough audience submissions, that is the next place.
There you go.
We will go. Leave a comment below, letting us know what you think about 3D printing for production, and if it's possible, and some of those challenges. If you liked this, feel free to share it with all of your friends on MySpace. Thank you for watching. We will see you in the next episode.
Have a great day.